This is the walkthrough video for PCTC 2022, round 2, question 6, array slicer. So with this question, we're given, so we start off with this array essentially, or this 2D list, or this grid, and we are given a series of instructions as our input, and our instructions tell us to chop off a certain amount of rows and a certain amount of columns. And we have to do this as we're given more and more instructions. And then finally, once the instructions are done, we then print off our final grid that we're left with. So the way I'm going to solve this is I'm going to start off by creating our initial grid and then really just go through each instruction step by step and basically just simulate it. So this isn't necessarily the most efficient code, but because this is only question 6, the code is probably good enough to get us all the points. I don't actually know. We'll see. So the first step is to create our starting grid. And to do that, we're going to create a 2D list. And I'm going to use list comprehensions just because it's faster, but it's perhaps less intuitive. But you can just expand these list comprehensions into full-on for loops. So I'm going to say so our inner one is going to be the x in range 10 because we want 10 rows and 10 columns. And then our outer list comprehension is going to be for y in range 10. And what we're going to do for each of those for loop runs, we're going to add a string to our nested list. And our string is going to be the y value and then the x value. And so what this should do is this should essentially just create a 2D array where each row is, so there are 10 sublists in our main list called grid, and each of those sublists contains these strings. And that's pretty much what this list comprehension does. Okay, so now we have our starting grid. Now we can take in our inputs and process them. So what I'm going to do is I'm going to take in one input at a time, process it, then take in the next input, then process it, as opposed to taking all the inputs at the start and then process all of them afterwards. Just because there's not really any point in doing it that second way, and that second way would require storing more information, and it's just more effort on our part. So we want to go through our main for loop as many times as our initial input says. So in this case, our initial input is 3, and so we're going to take in 3 inputs. So let's say our instruction is going to be whatever our input is. And now let's extract the useful parts of our instruction. And so the useful parts are going to be this integer and this integer. And we both know, we know that both integers are always going to be a single digit as opposed to a double digit number, because our grid is only 0 to 9. Our grid is only 0 to 9. So what do we call them? Let's call them start and end. So start and end are going to be equal to instruction, and it's going to be index 1 of the input. That's going to be our start, and our end is going to be instruction. It's going to be index -1. So that's the last character in our string. And these are both still strings. So let's convert them into an integer so that we can actually use them and do maths on them. Okay, so now we have our start and end integers. Let's now figure out whether we're dealing with the row or the column, and we'll have different code depending on what we're doing. So if instruction 0 is equal to row, so if we're dealing with rows, then let's run this code. And the code is going to be literally just a simulation. So we're going to go through from the start to the end number, and for each of those, for that many times, we're going to delete a whole row from our grid. And so in practice, that looks like this. So we're going to say for I, again, our variable I doesn't matter. Our variable I up here didn't matter. Our variable I down here doesn't matter. So actually better practice is just to call it underscore. And underscore in for loops basically just means I'm not going to bother with this variable because I'm never going to use it. So for underscore in range, and what we're going to put in this range brackets is how many times we want to chop out a row. And how many times we want to chop out a row, that's going to be our end minus our start. That's going to be 7 minus 1. So we're going to chop out 6 rows. But if you pay close attention, it says inclusive. So we want to chop out not 6 rows, but 7 rows. We want to chop out row 1 and row 7, as well as all of the 5 in between them. And so instead of just doing end minus start, let's do end minus start plus 1 to account for that extra 1 that we're chopping off. And we're going to repeat this code this many times. And what's the code actually going to be? It's going to be taking our grid and popping or removing that row. And what's the index of the row? The index of the row is start. Because at first, we're going to chop out row at index 1. But then since that's already chopped out, the next time to chop out row 2, we're actually now chopping out row 1. Because when we chop out row 1 right at the start, everything below that's shifted up 1. So where row 2 now is actually row 1. And so we can just keep chopping out row 1 until we've chopped out as many rows as we're meant to chop out. You can kind of think of it like, I don't know, like a stack of something, a stack of dominoes. If you remove domino at position 1 above the ground, then every other domino is going to move forward a position. And therefore, the next domino above that you want to chop out is also going to be position 1. And so that code is literally all we need for the row part. Now, what if we're told to chop out a certain amount of columns? This is much, much harder, and I can't really be bothered to go through the logic of that. I'm sure you can do it. It's not going to be that difficult, and you can still do it in a few minutes, but it's just more effort, and I don't want to go through that effort. So what we're going to do is we're going to copy our code from the row exactly as it is, and to make sure this still works, because obviously this code wouldn't work. This code should chop out rows and not columns. To make sure this code chops out columns and not rows, what we can do is we can transpose our grid. Transposing a grid just means rotating it 90 degrees. So we're going to rotate our grid 90 degrees. That's not what it means, actually. Yeah, so transposing, no, ignore that. Transposing is swapping the rows with the columns, essentially. So when you transpose a grid in maths or in computing, you're just swapping out the rows and the columns. And so if we transpose the grid, then apply the row code and then retranspose it back, what we've done is we've essentially just chopped out all of the columns while still having the correct grid at the end of this. So how do you transpose something in Python? We're going to say list zip asterisk grid. So I'm not going to explain how this works. Feel free to experiment with it and figure out how that works. But this is the command you can use to transpose something. So this is the command you use to swap the rows and the columns, and let's swap them again afterwards. And so just to reiterate, what we're doing is we want to chop out the columns, and so we're going to switch out the rows and columns, chop out the rows, then switch out the rows and columns again. And this is just a much, much faster way of achieving this. This is probably more inefficient, but that hopefully shouldn't matter. It's easier for us to code, it's faster for us to code, and so that's what we're going to do. And generally, I would say that if you ever have a competitive programming problem where you have a grid and you need to deal with rows and you need to deal with columns, and you're time pressured, which most things are, instead of having to bother write row code and then write the whole logic again for a column, which is slightly different, just write the row code, then copy paste it for the column code, and just transpose your grid before and after, just exactly as we've done here. And it's way, way faster for you to code. And as long as you're not basically told off for using too much time in your problem, then it's fine, because this isn't very efficient. But most of the time, this will be efficient enough to get you those points. Okay, so we've basically done all of the computation we need. Now we just need to print out the answer, which again, in this problem is going to be not that easy because we need to format our answer in a very specific way. And we want to print out each row. So let's go for row in our grid. We want to print out the row, but this will just print out the list. And so we want to unpack it by adding the asterisk at the beginning. And what unpacking will do is it'll print out every element in our list with a space in between them, exactly as we want here. Again, feel free to experiment with this yourself to make sure you understand what unpacking is and how we've used it in this case. Yep, that's 10 out of 10. Okay, so just to reiterate what we've done, or like the architecture of our code, is we've got a starting grid, then we're literally just applying the actions by chopping out the relevant rows and the relevant columns, and then we have our end grid like that. And yeah, keep in mind this idea of transposing. And in this case, as we saw, we weren't penalized for having really inefficient code, which is good, because it means we could write it like another 2 or 3 minutes faster. So remember this cool trick.